Welcome back. In this video, we're going to start chapter 7, which is a look at factoring. As always, when we start a chapter, it's a good idea to look ahead and see what it is we're getting into before we get into it. This chapter has 6 total sections in it. As I said, it's about factoring. Section 7.1, it says greatest common factor and factoring by grouping. So this introduces the idea of what factoring is and two kind of frequently occurring ways of doing factoring. Then from there, it starts to get a little bit more specific. Section 7.2, factor trinomials of one specific form. Trinomials, as you recall, are polynomials that have 3 terms. So this is specific to polynomials that have 3 terms. 7.2 and 7.3 are about how you do it for 2 specific forms. Okay, 7.4, factoring special products. So when we worked on multiplication, we saw how to kind of speed multiplication by identifying certain forms, such as perfect square trinomials and differences of squares. And so this kind of takes another look at that from a factoring perspective. 7.5 kind of sums it all up. And we come up with a kind of a general strategy for factoring polynomials and see some examples. Section 7.6, we shift away from expressions and start working on equations. And we use factoring as a technique for helping us solve certain kinds of equations. So that's basically where we're headed. And in this video, we're going to start 7.1 by looking at common factors. So the first kind of part here is just to remember how multiplication and factoring are related. Multiplication turns a product into a sum. Here we have 4x times x plus 3. That is a product of 2 things. If we go ahead and multiply that using the distributive property, we'll have 4x times x, which gives us 4x squared, and then plus 4x times 3, which is 12x. So that turned it from the product in blue to the sum in black. Factoring goes the other direction. Here we have 2x squared plus 8. This is a sum of 2 terms. And you'll notice that there's a 2 and an 8 here, and both of those are even. So they have 2 as a factor, and that'll get to that common factor idea that we'll get to in just a moment. But we can rewrite this using the distributive property as 2 times x squared plus 4. And if you like, you can always double check by multiplying that back out to see that you would get, in fact, 2x squared plus 8, just as we had started with. The point for this, though, is that where multiplication turns a product into a sum, factoring turns a sum into a product. Also, by the way, the word factor is used in a couple of ways. It's used as a verb telling you to do something, like here, factor the number 24. You could write it as 3 times 8. There, I factored it. Verb is an action word, and it means to do something. And in this case, it's write it in terms of a couple of other numbers. Factor is also a noun. We use it to refer to the parts. In this case, we could say that 3 and 8 are both factors of 24. There we've used the word factor as a noun as well as a verb. Okay, the next idea, we want to look at the idea of greatest common factor. Here we kind of want to read that from right to left almost. A factor, of course, is a number or term that we could multiply together to get something else. So, for example, we saw that 3 and 8 were factors of 24 above, or 6 and 7 are both factors of 42. Common factor, that doesn't mean that they're just laying around everywhere you look. They mean more like in common. What factors do they have in common? Taking a look at our example below, we have 48 and 80, and you could think about, well, there's some factors or numbers that divide into both of those. 48 and 80 are both divisible by 2. 48 and 80 are both divisible by 4. 48 and 80 are both divisible by 8. Out of all those different factors that they have in common, which is the greatest? That's the greatest common factor. So for 48 and 80, their greatest common factor is going to be 8. How you could see that would be to kind of factor both of those. 48, we'll write its prime factorization. That's 6 times 8. Factor this a little more. 6 is 2 times 3. 8 is 3 factors of 2. Okay, so this is 4 factors of 2 and a factor of 3. Let me factor 80 next. 80 is going to be 16 times 5, so that will be 4 factors of 2 and then a 5. So the greatest common factor looks like actually is 16. I thought it was 8 a minute ago, but no, it looks like it is 16. They have 4 factors of 2 in common. It's 16. I forgot the 16 divided into 48. 16 is actually the greatest common factor. Okay, next we want to find the greatest common factor of 12x squared and 18x cubed. Here there's a variable part as well as a constant part. Taking a look at 12 and 18, we want to think about the largest number that the two have in common. I know that both are divisible by 2, and 3, they're divisible both by 6. So 6 is the greatest common factor of the number part. And then x squared and x cubed. X squared has 2 factors of x. X cubed has 3 factors of x. We'll take the minimum of those two because that's what they share. And that will be 6x squared. 6x squared will be the greatest common factor of those two terms. Okay, the next one, there's a number part. A, powers of A as a factor and powers of B as a factor. Okay, we want to take a look at the greatest common factor of 6 and 8 first. 6 and 8 are both divisible by 2. That's the largest number that divides into both. And then A and A squared, we'll take the smallest power of A that we have. Here there's just A to a first power. And then B to the fourth power in the first part and B in the second part. The smallest of those powers of B will just be 1. So it will be 2AB, the common factor between those two. We use that idea of finding the common factor of a couple of terms to help us factor using the distributive property, and that part is next. So let's remember the distributive property briefly. The distributive property lets us turn or reverse order of operations in a way. If we have A multiplied by the sum of B and C, we can rewrite that as the sum of two products, that is A times B plus A times C. That is, call where you can get or how you can think of the distributive property. One way is in terms of areas of a rectangle. Let's say that we had a rectangle that was 3 inches high and maybe 10 inches wide. I know 3 times 10 is 30. And so that would tell us that the area is 30 square inches. Or we could look at it as the sum of the two smaller boxes' areas. 3 times 4 is 12. 3 times 6 is 18. 12 plus 18 makes 30. Okay, and that's a kind of an illustration of how the distributive property works. That is, 3 times 4 plus 6 is equal to 3 times 10. That's also equal to 3 times 4 plus 3 times 6, 12 plus 18. Those two, 12 plus 18 and 3 times 10, are both equal to each other. That's the distributive property. We use that all the time to help us multiply. Here we're doing factoring, which is going the other direction. So we're going to use it to factor. We want to factor 6a plus 24. Taking a look, there's a sum of two terms here, both of which have 6 as a factor. So we'll use the distributive property, put the 6 outside. 6a divided by 6 will be a, and 24 divided by 6 will be 4. So we'll get 6 times a plus 4. Remember when you were factoring that you could always double check by multiplying. If you're confident with your multiplication, that helps. 6 times a is 6a, and 6 times 4 is 24. That would take us back to where we'd started. Okay, 2b plus 14. Here there's a common factor of 2. If we factor out that 2, we'll be left with b plus 7. Okay, we have more examples to come. Let's take just the first 3 here. Okay, the first one, we have 11b plus 11. There's a sum of two terms, each of which has 11 as a common factor. If we factor out that 11, we should be left with b plus 1. Okay, take a minute and pause the video here and try parts B and C yourself, and then restart the video and see how you did. Okay, let's take a look. 12x minus 60. So here, 12 and 60 both have 12 as a common factor. So if you factor 12 out, you will be left with x minus 5. Before I go on to C, I did want to note the following. If you looked at 12x and 60 and thought, okay, well, I can see that both 12 and 60 are divisible by 6, so let me factor out a 6. That would leave 2x minus 10. It's true that 6 times 2x minus 10 is equal to 12x minus 60. They're equal. But typically when we factor, we want to factor out as much as we possibly can. So for this one, 12 times x minus 5 is better in the sense that you can't factor out anything else. Here, 6 times 2x minus 10, when you see this 2x minus 10 there, those two terms have 2 as a common factor. When you're factoring, you want to factor as much as you can. So you don't want to leave behind any factors, as I've done there. So this is not quite right. I mean, it's still equal, as I'd said, but when we factor, factoring is like simplifying. You want to go all the way with it when you can. Okay, here we've got 5x squared minus 25x plus 15. Here's a trinomial. We're going to factor out that common factor of 5 that you see. That will leave us with x squared minus 5x plus 3. And as far as trying to factor any more out of the inside, we'll save that for another time. Okay, we've taken out all the common factors that we can. Okay, so next up, let's try 3y squared minus 12y plus 27. Here, 3, 12, and 27, the largest number that divides into all three of those is going to be 3. That will leave us with y squared minus 4y plus 9. Okay, here are two more to try. E and F. Take a minute, pause the video, and try these two yourself, and then restart the video and see how you did. Okay, for E, 2 and 12 both have 2 as a common factor, so we'll factor out the 2. But additionally, we have x cubed and x squared. The smallest power of x that they both have, at least, is x squared, so we're going to factor out x squared. So we had 2x cubed. If we factor 2x squared out, there will be a single x left behind. Plus 12 divided by 2 is 6. And then we factored out the whole x squared, so there's no x left here after the 6. So the final answer, 2x squared times x plus 6. Once again, double check by multiplying if you like. Okay, 20x cubed minus 10x squared plus 14x. 20, 10, and 14 are all even, so I know I can factor a 2 out, and that's as good as it gets. When I saw the 20 and the 10, I was very hopeful that I could take 10 out, but 10 doesn't divide into 14. So the best that we're going to be able to do is to factor out the 2. But wait, I can factor some x out as well. We have x cubed, x squared, and x. We'll factor out a single x. That will leave 10x squared, and then minus 5x plus 7. Okay, once again, let me check. 2 times 10 is 20. X times x squared would be x cubed. That's good. 2x times 5x is 10x squared, and it's a negative. And 2x times 7 would be 14x. Okay, so that looks good. All right, last one. This has got 2 different variables in it, but that's okay. I will be careful. We have 9, 6, and 21. So the greatest common factor there is going to be 3 as far as the numbers go. And then let me see what letters they have in common. I see let's do x's first. I like to go in alphabetical order. So x, x squared, and then The last one doesn't have an x in it, so I guess we're stuck. I can't do that. Y's, we have y squared, and a y cubed. The smallest or greatest one that they all will have will be y squared. So we can factor y squared out. That will leave 3x for the first term. For the second one, it was 6x squared y squared. We factored 3 out, so that will leave 2. We weren't able to factor out any x's, so the x squared will still be there. There was a y squared. We're factoring out y squared, so there won't be y squareds any longer. And then the last term was 21y cubed. We factored 3 out. That will leave 7. And it was y cubed. We factored out y squared, so 2 of the y's. That means 1 y will still be there. Okay, all right. So that's a handful of examples. Make sure that you follow those. And if you have any questions on those, let me know. Okay, when the leading coefficient is negative, then the greatest common factor will be negative. So here we have negative 8y minus 24. I could see that I could factor out either 8 or negative 8. It looks cleanest if you factor out the negative 8. So let's do that. We'll factor out negative 8. That will leave y plus 3. Okay, make sure that you follow that. Again, if you distribute, you'd have negative 8y minus 24. All right, a couple of more examples. Negative 16k minus 64. Here, the common factor is negative 16. Factoring out negative 16, we'll have k plus 4. Next one has some b's in it. Negative 4b squared plus 16b. The leading coefficient's negative. I'm going to factor out a negative 4. Negative 4b, actually. I almost forgot to do the letter. I wouldn't want to do that. Negative 4b comes out. That will leave us a b. And then since I've factored out a negative, in order to have that middle sign end up plus, we'll have to have a minus in here. Negative times a negative will be positive. So b minus inside of the parentheses. And then here we had 16b. I factored out negative 4b, so we'll have negative 4 left. Let me double check and make sure I didn't make a mistake. Negative 4b times b is negative 4b squared. Negative times a negative is positive. 4b times 4 is 16b. So it looks good. Okay. Step up in complexity here. So make sure that you're comfortable with the preceding examples, really, before we go on. Okay. Sometimes the common factor is a binomial. So here we have 4a times a plus 3 plus 7 times a plus 3. Overall, this expression is a sum of two things. 4a times something plus 7 times something. That something is a plus 3. Instead of having just a variable or something as part of our common factor, let's say 4ax plus 7x, here I'm sure that you could see that x would be our common factor. We'd factor that out, leaving 4a plus 7. Here our common factor is that a plus 3. We're going to go ahead and factor that out. A little bit emphasized. That's our kind of common element. Okay, so we're going to factor out that a plus 3. Okay, factoring out that a plus 3 will leave us with 4a plus 7. And that's our final answer. Frequently, when I show this to people, they'll say, okay, well, what happened to the other a plus 3? Well, we factored out the a plus 3, so we're only going to end up with one of them that we're writing, and then what's left behind is the 4a plus 7. In other words, what happened to this 4a plus 3? The other one is, you could ask yourself the same thing over here to the right. What happened to the other x? When I turned 4ax plus 7x into x times 4a plus 7, what happened to the other x? Well, it got factored out, and you could double check by distributing, and you could also do that with our binomial here if you so chose. Okay, let's try this next one. we have 8x times x minus 4 minus 5 times x minus 4. You want to try to get into the habit in cases like this of just looking at that x minus 4 as just one thing, like a whole chunk. So this is 8x times something minus 5 times that same something. So let's again kind of highlight that. X minus 4, we're going to treat that as a unit. Or one big piece. So we have 8x times something minus 5 times something. We'll factor out that something they have in common. What's left behind is 8x minus 5. Okay, and that's the end of that. That idea of factoring out a binomial is the kind of the basis for how factoring by grouping works. And this is the last topic for this section. So we're getting there. Factoring by grouping is the first of the, really the second of the techniques that we'll see. The first one was factoring out a common factor. Factoring by grouping is something you want to think of using whenever you're looking at a polynomial that has an even number of terms. For our purposes, it's going to be 4. But if you ever saw 6 or 8 or 10 terms somehow, wouldn't happen in our class. But if you did, you'd want to think of factoring by grouping. Taking a look at this first example, we've got xy plus 8y plus 3x plus 24. Our first thing we would want to try is to look for common factors. Looking at the first two terms, we have xy and 8y. Oh, good, they have a y in common. However, moving on, there's no y's that the rest of it have in common, so we can forget about that. Continuing though, I can see that the first and third one have an x in common, but they don't all have x's. The second and fourth terms, 8y and 24, are both divisible by 8, but there's no more 8's. For the last two terms, 3 and 24 are both divisible by 3, but the other stuff isn't. So it's kind of like there's some stuff that is in common, but nothing in common to all 4 terms. So I can't take out a common factor here. However, if you look at the first two terms and group those, which is why it's called factoring by grouping, if you group the first two terms together, let's go ahead and wrap those in parentheses for emphasis, and the second two terms, then you can factor common factors out of those pieces. So xy plus 8y has a y as a common factor. If we factor that out, we're left with x plus 8. The second two terms, 3x plus 24, have a 3 in common. And if we factor those out, we'll be left with x plus 8. This turns it into one of the examples like this that we did before, where there was a binomial as a common factor. This just kind of adds that step onto the beginning where we need to create those two binomials. Here it's x plus 8. Okay, so now we can factor out the x plus 8, and we'll be left with y plus 3. Okay, so using that one kind of as a model, take a minute, pause the video, and try this next one. We've got AB plus 7B plus 8A plus 56. All right, let's have a look at this one. For this one, again, there are 4 terms, and we can see some kind of common elements. I know the first two terms have a B that they share. The first and third have an A. The last two terms have an 8 and 56, and both of those are divisible by 8. 7 goes into 56 8 times, so I'm kind of seeing that kind of pattern show up here. So let's take a look at the first two terms. Let me group those together. We'll have AB plus 7B. And then the second two terms, which are 8A and 56. The first two terms have a B that they share, so let's factor the B out. That will leave us with A plus 7. In the second two terms, we can divide out or factor out an A, and that will leave A plus 7 again. Okay, now you'll notice that the two pieces in parentheses, those two binomials, are the same, and that's a necessity for what we're doing here. If they're not the same, you can't continue. So either you've made a mistake or it doesn't factor in this way. But here we're okay. So we'll factor out that a plus 7, and then that will leave behind b plus 8 for our other factor. All right, good. So here's one more to try. Take a minute, once again, pause the video, try this one yourself, and then restart the video and see how you did. All right, let's take a look at this x squared plus 2x minus 5x minus 10. So for the first two terms, we have x squared plus 2x. Then for the second two terms, I'll go ahead and write that as plus negative 5x minus 10. For the first two terms, there's an x that is in common. So if I factor the x out, we'll be left with x plus 2. For the second two terms, I'm going to factor out a negative 5. We'll have negative 5, and that will leave us with, again, x plus 2. Once again, no common factors for all four terms, but common factors if we group them. So let's factor out that common factor of x plus 2, and then we'll be left with x plus negative 5, which is the same as x minus 5. For this one, while you were working, I was thinking about it, and I realized that you can rearrange this slightly, and it will still work out. So just for fun, let's take this original expression and rewrite that as x squared minus 5x plus 2x minus 10. Here you can see that I swapped those middle two terms. So addition's commutative, so we're allowed to do that. So now the first two terms have x as a common factor, and that will leave x minus 5 when I factor it out. The second two terms have 2 as a common factor, and again, that will leave x minus 5. Doing it this way, x minus 5 is the common factor, and we're left with x minus 5 times x plus 2, which is the same as what we had before. It's just the factors are written in the other order. So I just thought that was kind of neat. Okay, we have just one more example, and then we're done with this section in this video. Okay, so bear with me. We are almost finished. So we've got y squared plus 4y minus 7y minus 28. Common factor of y. Factor that out. We'll be left with y plus 4. Then common factor of negative 7. That will give us y plus 4 left behind. Okay, this time our common factor is going to be y plus 4. And then if we factor that out, we're left with y minus 7. Okay, and that will be the end. I'll leave it to you if you want to rearrange the middle two terms on this one and see how it comes out. You can do that. Okay, that takes us to the end of this video. We talked about what factors are, the relationship between factoring and multiplying. We talked about the greatest common factor. We talked about how factor is both a verb and a noun. We practiced factoring common factors out. We saw that factors can sometimes be binomials. And then we did factoring by grouping. And so there's a lot in this section. And so you may want to watch this video more than once. Often the first section in a chapter has a lot of stuff in it, a lot of definitions and new ideas. So that happens. And so if you're a little lost at this point, that's okay. It'll get better with practice. And again, rewatching the video may help. In the next one, we'll be going on to some specific techniques for working with factoring trinomials. In the meantime, let me know if you have any questions, and have a great day.